Okay, so in this particular section, we are going to be doing some sketching of graphs and basically of functions that are rational. Remember what the word rational means. It's a fancy name for a fraction. Now notice the directions. The directions want us to not only sketch the graph, they want us to find any intercepts, any asymptotes, any extrema, where it's increasing and decreasing, any points of inflection, and any concavity. So sketching is going to actually be the last thing we do. We're going to take this in order of how they've actually done it, or they've written the directions. But the sketching part really is going to be last because we can't sketch until we get everything else situated here. So the first thing they want are intercepts. So let's take care of that first. If I want to find the x-intercept, remember, you let y equal 0, which means the whole equation is set equal to 0. I'm going to multiply both sides by the denominator, which is going to cancel out the x minus 5. And anything times 0 is still 0, which means I end up with 0 equaling 1. So do I have any x-intercepts? Nope. So no x-intercepts. Now let's see about the y-intercept. So to find the y-intercept, we let x equal 0, which means we end up with f of 0 equaling 1 over 0 minus 5, which means we end up with a negative 1/5. So in this particular case, I do have an x-intercept. It is the point 0, negative 1/5. Okay, done. Asymptotes is next on our list, right? So intercepts are done. Asymptotes. Remember, let's keep this in order, just like we discussed. The first asymptote we're going to find is the vertical asymptote, because it's the most important one. Remember, that is finding what number will make our denominator equal to 0. And in this case, that's going to be a positive 5. So I do have a vertical asymptote. Done. Horizontal asymptote. So remember, for the horizontal asymptote, you are basically finding the limit. So we look at the top, we look at the lead term in the numerator and the lead term in the denominator. That's going to be 1 over x, right? So I'm going to find the limit as x approaches infinity of 1 over x. So remember, as x gets larger and larger, the whole fraction becomes smaller and smaller, doesn't it? Till it eventually looks like it's 0. So the limit is going to be 0, which means my horizontal asymptote is y equals 0. Remember, horizontal is a y line. Vertical is an x line. So oblique asymptote is next on my list. Now remember, if we have a horizontal asymptote, do we have an oblique asymptote? Nope. So I have no oblique asymptotes. So asymptotes are done. Check. Okay, so next thing on our list is the extrema, relative extrema. So remember, to find the relative extrema, I need to find the critical value. And to find the critical value, I need the first derivative. So I'm assuming you remember how to take the first derivative. But if not, let me go ahead and run this through. I personally need or would like this function written with no denominator. So I'm going to rewrite the function so it is x minus 5 to the negative first power. The power rule says bring this down. So down comes the power reduce it by 1, and then take the derivative of the inside, which is going to be 1. So my first derivative is going to be 1 over, negative 1 over, x minus 5 to the second power. And we are supposed to take this and set it equal to 0 to find the critical value. Again, when we're solving an equation, it's quicker to solve it without a denominator. So I'm going to multiply both sides by this denominator. And again, anything times 0 is still 0, which is going to leave me 0 equaling negative 1. Is this a true statement? No. So in this particular case, this method of finding the critical value isn't working for us. According to this, I don't have a critical value. So I have to go with option B. So there's no critical value by this method. The second option of finding the critical value, option 2, was finding the number that will make the original not exist. So in this particular case, or excuse me, make your derivative not exist, x equaling 5 makes this a do not exist situation. So this would be the critical value I'm working with, x equals 5. Okay, now that I have a critical value of x equaling 5, because that makes your first derivative not exist, I am now needing to find if it is a relative min or a relative max. So we are going to do some testing, and I'm putting the 5 here because that's what my critical value is, and we're going to be doing some testing. So we are going to test a number to the left of 5 and the right of 5. So I am just going to use x equaling 4. Now remember, when you're testing, you plug it into the first derivative. So I am going to find what the value of the first derivative is when x equals 4. So 4 minus 5 squared. I simplify this. And what? I get negative 1 down here. Squared is a positive 1. So I end up with negative 1 over positive 1, which is negative 1. All right, so this tells me that from negative infinity to this 5, I have it decreasing. And by the way, if you recall, isn't 5 a vertical asymptote? Which means this will be an open circle, wouldn't it? Which means this would be a parenthesis, right? So on this particular interval, I have it decreasing, don't I? Let's check the other interval. I'm going to use x equaling 6. I'm going to plug it into the first derivative. And again, the denominator here is going to be 1. Squared is 1. Negative 1 over 1 is still negative 1. So in this particular case, again, 5 is a vertical asymptote, so it needs a parenthesis. From 5 to infinity, it is decreasing. Still, it's decreasing. So answer me this. If both sides are decreasing, do I have a relative extrema? You're right. No relative extrema. I'll write it up here so you can see it. I have no relative extrema here. So I looked for the relative extrema, don't have it. At the same time, I found where it was increasing and decreasing. So that is now done as well. Okay. Okay, next on my list is finding the points of inflection. So to find the point of inflection, I need the second derivative. This is what I need to find, is the second derivative. So again, me personally, on my first derivative, this is what I ended up with, correct? I personally don't want the denominator again, so I am going to rewrite this as x minus 5 to the negative second power. So to take that derivative for the second derivative, I have negative 1, bring down the power, reduce the power by 1, and then multiply by the derivative of the inside, which is just going to be 1. So in this case, I get a positive 2, which tells me derivative number 2 is going to be 2 over x minus 5 to the third power. Now, we're going to do the same exact thing we did when we were trying to find relative extrema. I need to take this second derivative and I need to set it equal to 0 to find the point of inflection. So notice, the process is the same. If I'm trying to find the critical value, which leads me to the relative extrema, I take the first derivative and set it equal to 0. When I'm trying to find the points of inflection, I am going to take the second derivative and set it equal to 0. So my process is the same. It just depends which derivative I'm setting equal to 0. If it's the first derivative equal to 0, it's the relative extrema. If it's the second derivative being equal to 0, I'm looking for the point of inflection. So we are going to take derivative number 2, set it equal to 0. If you notice, I'm going to multiply both sides by this denominator, which leaves me with 0 equaling 2. So by this method, there's no point of inflection, which means I have to go to method number 2. And method number 2 is just like method number 2 was when I was trying to find my critical value. I am going to find what makes the second derivative not exist. And in this case, x equaling 5 makes derivative number 2 not exist. So this is the x value that I am going to look at. So far, so good? Okay. Okay, now, looking at the point of inflection, I have the number 5, x equaling 5. I am going to do some testing to see what's going on. Now remember, you're dealing with derivative number 2. So now when I choose my x values, I am going to plug them in to derivative number 2. So I'm going to choose x equaling 4 on this side. And when I plug that into derivative number 2, this is what it looks like. Well, 4 minus 5 is negative 1. Cubed is negative 1. 2 divided by negative 1 is still a negative number. It is going to be negative 2. Since this is less than 0, I'm dealing with derivative number 2. Derivative number 2 deals with points of inflection and concavity. Since this is less than 0, this tells me it concaves down. From negative infinity to 5. And again, there's a parenthesis around the 5 because 5 was a vertical asymptote we need to remember. So can't put a bracket on that. Okay, let's test the other side. I'm going to choose x equaling 6. Again, plug it into derivative number 2. And when I plug it into derivative number 2, 6 minus 5 is 1. To the power of 3 is 1. 2 divided by 1 is still 2. So my second derivative at this number is greater than 0. Again, you're dealing with the second derivative, which means you're dealing with inflection points and concavity. This tells me that since it is positive, it concaves up on the interval 5 to infinity. So, I have found my concavity, okay? I have also, sorry, my brain went on a little sidetrack there. I have found that 5 is actually still a vertical asymptote. It is not an inflection point, okay? So here's something I want to recap before we start sketching. If you want to find your relative extrema, you need your critical value, correct? Which means you need the first derivative. Your first derivative helps you find the critical value, helps you decide where it's increasing and decreasing, and also helps you determine your extrema. So understand that. Derivative number 1 helps me with the relative extrema and the critical value and where it's increasing and decreasing. Derivative number 2 helps me with inflection points and helps me with concavity. The process is the same for both. Once I find these derivatives, I have to set them equal to 0 so I can either find the critical value or a possible inflection point. And then I test, and depending on which derivative I'm working with, I'm either testing for increasing and decreasing, or I'm testing for concavity. The process is the same. It just depends on which derivative you are working with, so you know if you're dealing with relative extremas or you're dealing with concavity. Okay, it's time to sketch. All right, so I have written all the information that we found out. We have a y-intercept of 0, -1/5. We have a vertical asymptote at x equals 5, a horizontal at y equals 0. We have decreasing on these two intervals. We have concaving down on this interval and concaving up on this interval. So, first things first, I know that I have a y-intercept at 0, -1/5. So there's my y-intercept, 0, -1/5. I know I have a vertical asymptote at x equals 5. I know I have a horizontal asymptote at y equals 0. I know that on -infinity to +5, this graph is decreasing and it's concaving down. So it decreases and it concaves down, which means on this interval, your graph, and it's crossing through here, is doing this number, decreases, concaving down. And some of you may be asking, well, why isn't it above here? Why doesn't it start above the x-axis? Well, first off, the x-axis is a horizontal asymptote. Secondly, was there a y-intercept above the x-axis? Since there was not, the only place it could have crossed was here. It couldn't have come up here and crossed, all right? Now, on the other side of the world, so to speak, we still have it decreasing on 5 to infinity, so it's still decreasing, but it's concaving up. So, since it concaves up and it's decreasing, then it is doing this number. And some of you may be asking, well, why doesn't it go below the horizontal asymptote? You know it could, because the horizontal asymptote is allowed to be crossed. But let me ask you this. Did I have any x-intercepts? No. So if I had no x-intercept, There's no way that this graph could have touched the x-axis on either side, which is another reason why over here it started below the x-axis and over here it's above the x-axis. How are we doing? Does that make sense? There is your sketch. There's the information we found, and there is your sketch. Hopefully that helps. Have fun.